Hi students, now the topic is electrochemical cell. Electrochemical cell. In this electrochemical cell, the chemical energy converted to electrical energy. The chemical energy converted to electrical energy in spontaneous chemical reactions. Okay, this cell contain like this structure. So the cell contain two half cells. So this is the one of the half cell, this is the one of the half cell, and it two contain two. These half cells contain electrodes. Two electrodes are present in this, and so two electrodes are connected with each other. And this is a solution taken in this electrolytic solution. In this also electrolytic solution. And so which of the electrode is taken in this half cell? Its salt solution taken as electrolyte. And this also, which of the electrode is taken in this half cell? Its salt solution is taken as a electrolyte. Okay, this is a salt bridge. Salt bridge. So this salt bridge, the ion balancing take place. Ions are balanced. The ions are balanced by the using of salt bridge. Okay, you observe in this. So this is a electrode and solution containing salt of zinc. So this is a solution as electrolyte. This solution is containing salt of zinc. So you take the salt of zinc is a zinc sulfate, ZnSO4. Okay, zinc sulfate, and this is a CuSO4, copper sulfate. Solution containing salts of copper sulfate. Okay, and this is a cell structure, cell, electrochemical cell. So these are in this there is no applying of external electrical energy. So in these chemical reactions are take place, spontaneous chemical reactions are take place. So the chemical energy converted to electrical energy is take place in this. That is observed by the using of voltmeter or ammeter. So you take the ammeter or voltmeter in this position. How much amount of electrons are flowed? That means how much amount of the current is, amount of the electricity is produced. That is find out by using a voltmeter or ammeter. For this also called as this is a electrochemical cells also called as Daniell cell or voltaic cell or galvanic cell. Okay, and this is a zinc sulfate, ZnSO4, and this is a copper sulfate. This is a zinc electrode, this is a copper electrode, and we initiated in this zinc is -1. Zinc electrode contain minus in this charge, and copper electrode contain plus in this charge because of in this the zinc is going to ionize. That means the zinc is going to ionize as Zn plus 2 formation by liberation of 2 electrons. 2 electrons are liberated by the zinc. So Zn plus 2 ions are liberated. Okay. So the electrons are flow from this electrode to this electrode by the following this way. Flow of electron flow is take place. So opposite of electron flow is current. Opposite of electron flow is current. Okay, so that is the reason the flow of electron is take place from this electrode. That is the reason we initiated -1 this one, and this is a in this position oxidation is take place. Oxidation means loss of electrons. So zinc is going to lose electrons. 2 electrons are lost. So 2 electrons are lost by the zinc. Zinc is liberated in this solution as Zn plus 2 formation, and electrons are going to flow from this way. Okay, electron flow is take place, and electrons are going to occupy in this position. So the electron flow is take place like this. So in CuSO4 contain copper is there. CuSO4 solution. In this copper is going to gain in this CuSO4. What is the state of this one? Cu plus 2 state, copper SO4 2 minus. Okay, so Cu plus 2 ions are going to gain this 2 electron. The copper ions are going to deposited in this electrode. Okay, and remaining this SO4 minus 2 ions are going to move from this salt bridge, and this SO4 minus and zinc plus 2. SO4 minus 2 and zinc plus 2. This is going to form ZnSO4. Are you understood about this? So, what happened in this? Electrode containing zinc. So, the zinc electrode containing zinc is going to form as Zn plus 2 formation by the liberation of 2 electrons. Electron will move from this electrode, zinc electrode, to copper electrode. So that is the reason we initiated this minus and we initiated this plus. Okay, electrons are absorbed by this electrode. That is the reason we initiated plus in this. So this Cu plus 2 going to absorb this going to absorb the electron from this electrode. So in this electrode position, what happened in this electrode position? What happened in this electrode position? Cu plus 2 plus 2 electrons gives rise to the Cu solid formation. So Cu solid formation is take place in this. So what happened in this? Electrons are gained by the copper plus 2. So reduction is take place in this. What happened in this position? Oxidation is take place. So oxidation take place at anode and reduction take place at cathode. So anode. So this electrode is anode and this electrode is cathode. So in this galvanic cell, anode is minus, cathode is plus. But in electrolytic cell, anode is plus, cathode is minus. So both one is opposite compared to the electrolytic cell and electrochemical cell. Anode charge is minus for this electrochemical cell and anode charge is plus for the electrolytic cell. Okay. So this is the comparison. We observe in equation point of view also. So ions are flow from by using of salt bridge. So SO4 2 minus are going to flow from the salt bridge and the zinc ions are going to stabilize it. So chemical energy to electrical energy take place in spontaneous chemical reaction in this electrochemical cells. So reactions take place into two different portions of the Daniell cells. Yes, reactions take place in two different portions. So this is the one of this portion, this is the one of the portion. So reactions are take place in this. In this also reaction take place. Oxidation is take place in this, reduction is take place in this. Total redox reaction is take place in this cell. Spontaneous chemical reactions. So the energy, the chemical energy, that means in thermodynamic point of view, we said Gibbs energy is converted. Gibbs energy is of spontaneous redox reaction is converted into electrical work. Okay. So these type of cells are maybe used in running a motor, other electrical gadgets like heater, fan, greaser, like that. Okay. So this is a galvanic cell. So we observed in reaction point of view. So this cell contain reaction and this cell contain reaction. Two portions we called as this is one of the off cell. This is one of the off cells. So two off cells are present in electrochemical cell or galvanic cell. Cell reaction. So what is the cell reaction take place in this? Oxidation, reduction, both one is take place in this cell. So we called as redox reaction. So redox reaction, we observe in this zinc solid zinc electrode converted to zinc plus 2 formation. That means 2 electrons are liberated by zinc and 2 electrons are gained by the aqueous. So the one of the off cell contain CuSO4 in that Cu plus 2 ions are going to absorb the 2 electron from the zinc. So it is going to stabilize as Cu solid at the electrode position, at cathodic electrode position. Okay. So this is a oxidation and this is a reduction. So total this reaction is redox reaction. Okay. The spontaneous redox reaction is take place in this electrochemical cell. Two portions are called off cells. So one is a oxidation of reaction, another one is reduction of reaction. So one of the portion contain oxidation. So Zn converted to Zn plus 2 plus 2 electrons. And reduction can take place in one of the off cell, that is Cu plus 2 plus 2 electrons, Cu solid. So these reactions are take place in the electrochemical cell or galvanic cell. I once again repeat in this one. Zinc solid is going to form as Zn plus 2. So zinc solid is converted as Zn plus 2 formation. Because of 2 electrons are liberated. So 2 electrons are going to flow. Electronic flow is take place like this. That is calculated by using ammeter or voltammeter. And this Zn plus 2 ions are liberated in this solution. So Zn plus 2 ion, actually this is a Zn SO4 solution, SO4 is there, and in this also Zn plus 2 ions also present. But how it is going to stabilize? So these Zn plus 2 ions are stabilized from the this SO4 ions. The SO4 ions are going to move from this salt bridge. Okay, salt bridge. We call bridge between the two portions. This salt bridge is present. So these SO4 minus are going to move from this salt bridge. So this SO4 and SO4 2 minus and Zn plus 2. So both one is going to form Zn plus 2 and SO4 2 minus. Both one is converted as Zn SO4. So Zn SO4 solution is going to form. Okay. And remaining. So remaining, which one is there in this solution contains Cu plus 2 ions. Cu plus 2 ions are present in this. Cu plus 2 ions are going to gain the electrons. So electron moving is take place in this electrode, from this electrode to this electrode. So electrons are present in this. So these Cu plus 2 ions are going to gain the electron in this electrode. So the Cu plus 2 ions are going to deposited in this electrode position. So the Cu plus 2 is converted as solid. That means depositation is take place in this electrode. Okay. So this is a oxidation and this is reduction. So this totally spontaneous redox reaction is take place in this galvanic cell. Which of the position reduction is take place? At cathode. Which of the position oxidation is take place? At anode. Okay. But charge of the anode is minus in this. Charge of the cathode is plus in this. Electrode potential. So what is meant by electrode potential? That means a potential difference. That means energy difference. Potential difference between the developed between the electrode and electrolyte. So the cell contain one of the off cell contain electrode and electrolyte is there. Electrolytic solution. So both electrode and electrolyte, the potential difference developed between the electrode and electrolyte is called as electrode potential. And next, standard electrode potential. The potential difference developed between the metal electrode and the solution of ions in unit molar. What is the meaning of that? So the off cell, one of the off cell. So for example, you take this off cell. This off cell contain electrode is present. Electrode. So electrode contain particular potential, and these electrolytes also contain particular potential. So both one, the potential difference developed between this electrode and electrolyte, that is called as electrode potential. Okay, electrode potential. And the standard electrode potential means the solution contain ions of unit molarity. Then what is the meaning of that? The solution molarity is unit molarity and at 1 atmosphere pressure and 25 degrees temperature. Okay, 25 degrees temperature. We take the cell potential. The potential difference between the two electrodes of the galvanic cell is called as cell potential. So galvanic cell contain two half cells is there. Galvanic cell contain two half cells is there. Okay, two half cells. In this, the potential difference between this electrode and this electrode. The potential difference between the two electrodes of the galvanic cell is called as cell potential. That potential is called as cell potential. So what are the electrodes? One is a cathode, another one is anode. So this is also called as EMF. That is electromotive force. Okay, electromotive force. And we write this one. E cell equal to E right minus E left. You take the E right minus E left. So that means cathodic minus anodic one. Cell reaction for this in this electrochemical cell, we take which one? Zinc, Zn plus Cu plus 2 gives rise to Zn plus 2 plus Cu solid. So this is Zn solid and this is a reaction. So in this, one is a oxidation, one is a reduction. So we write the cathode What is the take place in this? Reduction is take place. Reduction is take place at cathode. So we write the half cell of this reaction at cathode. Cu plus 2 electrons gives rise to the Cu solid. So this is a reaction. And at anode, what is the reaction is take place at anode? Oxidation. Oxidation is take place in this. So we are going to write this reaction as Zn, going to form as Zn plus 2 electrons. So this is a reaction of one of the half cell and another one of half cell. So we are going to write the cell representation. So the galvanic cell representation or electrochemical cell representation like this. Okay, anode is left side. Anode is, which one is there in this? Zinc. Okay, Zn. Okay, this is a Zn solid state electrode and its electrolyte solution. So we initiated Zn plus 2. Okay, Zn plus 2 or aqueous condition electrolytes. And between the this is one of the half cell, and we initiated these two lines. These two lines means, what is the meaning of these two lines? So this is a salt bridge. Okay, salt bridge. And this is a anode, and next we take the this is the anode. Next we take the cathode. So cathode Cu plus 2, and this is next electrolyte is, this is a electrolyte Cu plus 2 aqueous condition, and this is a electrode as Cu solid. So this is a galvanic cell representation. I once again repeat this one. So this is a cell reaction, half cell reaction. This is another one half cell reaction, reduction of cell and oxidation of cell. So we write in this first one is anodic half cell, and this is a cathodic half cell. Anodic half cell is what is the electrode? Zn, zinc solid, and electrolyte is Zn plus 2. Okay, Zn plus 2, and this is indicated for the salt bridge, and Cu plus 2 electrolyte and oblique Cu solid. So Cu solid, this is electrode and this is electrolyte. So we are going to represent this as a galvanic cell representation. And another one example. So you take Cu solid plus Ag plus aqueous condition gives rise to the Cu plus 2 plus Ag solid. This is aqueous. So what is happening in this? Cu is converted to Cu plus 2 state, and Ag converted to Ag plus converted to Ag. So what happened in this? In this, Cu is converted Cu plus 2. Oxidation is take place. Oxidation. This is a oxidation. Oxidation is take place. How many electrons are liberated by the Cu? 2 electrons. Okay, but Ag plus is converted to Ag. How many electrons are gained by this Ag? Only 1. So you initiated 2 in this position. Balancing. So 2 Ag plus, that means 2 electrons are gained by the silver ion is going to form Ag solid phase. So you take in this also 2 Ag solids. So this is a cell reaction. So this absorption, gaining of electrons take place. So this is a reduction. So we are going to represent the galvanic cell representation or electrochemical cell representation. So oxidation is take place at anode, and reduction is take place at cathode. So we take the first one is anode, and next one is cathode. Anodic half cell and cathodic half cell. You write the first one is half cell of cathode half cell. Cathode portion, which one is take place? Reduction is take place. So what happens at the cathode? 2 Ag plus gives rise to 2 Ag solid. What happens in this? By the gaining of 2 electrons. Okay, And anode, at anode position, what happened at anode position? Oxidation is take place. Okay, at anode position what happened? Oxidation is take place. Cu converted to Cu plus 2 plus 2 electrons. These 2 electrons, these are okay. So this is a oxidation of oxidation at anode, and we represent the total cell representation as a galvanic cell point of view. You take the first anode, that is first electrode Cu solid and Cu plus 2 electrode, okay, and what is the representation of these two lines? Salt bridge, and next Ag, electrolyte Ag plus oblique Ag. So this is solid place. So this is a galvanic cell representation. Another one example. Also you take the any reaction, okay, any redox reactions. You write the any redox reaction by the following this way. This is a anodic one, this is a cathodic one. You write the E cell equal to what is the E cell equal to? E right minus E left. What is the right? This is the right, this is the left. Okay, so anode minus cathode minus anode. We are going to write E. Right, which one is there? Right side is this one, Ag plus Ag. Ag plus Ag minus E left. Which one is there? Cu by Cu plus 2. So this potential, E cell potential of the galvanic cell.